First video, we introduced the method. This video, we're going to use it. So let's get right into it. Example 1. Find the volume of the solid of revolution formed by revolving R about the y-axis. Part A is going to be R is defined in this way. So we have this function. Call this function f of x is 1 over x. And we're just looking from x equals 1 to x equals 3. And this is our region. That is our R. We're rotating it about the y-axis. So I'll denote that like this. And I want to compare. Before we even use the shell method, what's this going to look like if we have the disk method? Well, if we have the disk method, first off, we have to get this in terms of y. That's not hard. And then it's going to be setting it up like this, right minus left. And we'll have two integrals, because this region is going to have these two constant functions as the bound for right and left. And then this other region is going to have the function and this constant function. Like so. So we'd have to use two integrals, and we could do that, and that'd be fine. And you know how to do that, and it'll work. But let's see what happens if we use the shell method. So the shell method says, okay, let's revolve each one of these little guys about the axis and get that shell shape, right? That's what we're doing. Rotating it around this way, finding the volume of one of these little shells and adding them all up. Okay, well, if we do that, we use the formula. The volume is 2 pi times the integral from a to b. Again, just using this formula. 2 pi integral from a to b. Well, that's easy. X is going from 1 to 3. Of x times f of x. That's it. Dx. Well, that's much nicer. That's much nicer than two different integrals having to split up the region. Look, this is just the integral of 1 dx. This is about as nice as it gets. Woohoo, shell method. Can I get some love for shell method? Every Calc 2 class I teach, nobody loves the shell method like I do. Everyone just loves the disk method because I think the disk method is easier to see. But look how nice this integral is. You know, I try not to abuse my position as an instructor by pushing my views on you guys. But I'm going to push this view on you, okay? And you could calculate this integral out. Gosh darn it. I was going to not do these out myself because I don't want to take the time in these videos to do them, because I know you can do them all on your own now. But this one is just so easy. I may as well, right? We get 4 pi units cubed. I make a lot of silly mistakes when I do these integrals quickly, but there's no way I made a mistake on this one, right? There is no way. All right. So that should be this volume. And if you set it up with the disk method, you would get the same thing. Hopefully. Let's do another example. Here, I'm not going to draw it to you. Oh, also, I want to show it to you. This is what we're doing in this last example. No, it's not. This is what we're doing in the last example, right? We have this region. We're rotating it about the y-axis. So we have this hollow cylinder here. And then we're looking at this volume of this other area over here. All right. And we calculate it to be 4 pi something units cubed. All right. Oh, look, the book has the answer. Great. I didn't mess that one up. That's why you always double check your answers. Again, I always say check your answers. It's not because I'm trying to do something other than me. It's because everyone needs to check their answers. We all make mistakes no matter how many of these calc problems you've done. So especially on quizzes and exams or calc videos. Let's do part B. R is the region bounded above by f of x equals 2x minus x squared, bounded below by the x-axis, and we're looking at the interval 0 to 2. So let's get a picture. Let's come up with our own picture. Should be able to do this by hand. All right, what do we know about this function? This is a quadratic function. What are the zeros of this function? Those are, if you know the zeros of a quadratic function, it's much easier to graph. The x-intercepts, well, we can just factor it. The zeros are at x equals 0 and x equals 2. We know it opens downward as well because the x squared term is negative. So we get something that looks like this. Pretend that it passes through those points. What's the region under the graph and above the x-axis? Well, it's this region. And we're rotating it about the y-axis. Again, this is a big pain to do with the disk method. Right? You'd have to first get things in terms of y, which, by the way, is not easy. First, you'd have to get things in terms of y, and then you'd have to split it up into kind of two functions. We did this a little earlier with an example that, if you remember, one of the homework problems with like arcsine, we did something similar. We had to split this into two regions, get the function, get this in terms of y for both of them, and then subtract them. Shell method coming in to save the day. So all we need, again, let's go back to the shell method. Do we have all this stuff? Continuous function, non-negative function, have the region bounded under the curve above the x-axis from A to B. Well, let's just use the formula. Let's just use the formula. I'm going to copy the formula down so we can use it a little bit more easily. This is the formula for revolving around the y-axis, which is what we're doing. Well, that's what we have here. 2 pi integral from 0 to 2 of x times f of x. We're basically done. Now we just evaluate this simple definite integral and we're good to go. Remember how products work with integrals? In derivatives, you need the product rule. Integrals, you need to get rid of products most of the time, or you can try a u substitution. U substitution is not going to be great here. We're just going to distribute. That'll give us 2x squared minus x cubed. And now we can antiderivative. We get 2/3 x cubed minus 1/4 x to the 4th from 0 to 2. And then we just evaluate and don't make silly mistakes. Leave that 2 pi out in front. It's going to be much easier if you do that. Plug in 2. We're going to get 2/3 times 2 cubed. 2 cubed is 8. Minus 1/4 times 2 to the 4th, which is 16. And we subtract what happens when you plug in 0, which gives us 0 minus 0. Okay, that's fine. This whole thing is 0. Now we simplify and try not to make a mistake. 2 times 8 is 16 over 3. A quarter of 16 is 4. And 4 is the same as 12 over 3. 16/3 minus 12/3 is 4/3. Multiply it out, we get 8 pi over 3. Units cubed is our volume. We're going to visualize this and check this with the book. Remember, most of these, not all of them, but many of my lecture videos are based on the book. So again, this is our region. Graphed it the same way we did. We didn't include a y-scale because the y-scale didn't matter for us. It didn't matter how high this went for our picture. Only mattered where the x's were. All right, and then again, we get this bundt cake, just like that bundt cake problem from 2.2. But now we're modeling it with a parabola, which is much easier than with a sine curve. And now I'm hungry. And that was our volume. And their answer is 8 pi over 3, just like we wanted. And that's the shell method. That's most of this section. There are, the future videos are going to make this, add a couple more curveballs that you can see, different strategies that you can use, but this is essentially it. Hopefully, I have taken one step in convincing you that the shell method can be nice. And I hope you have a great day.